You know, every time you turn the key in your ignition, you're actually interacting with the machine born from an absolutely fascinating story. It's a story of insane logistics, cutting-edge robotics, and sheer human ingenuity. Welcome to this explainer. Today, we're going to completely demystify the incredible journey of how a modern automobile is built. We'll trace the whole shebang, literally from a designer's initial sketch all the way to a fully functional machine rolling right off the assembly line.
But first, to really wrap our heads around the sheer magnitude of this process, we got to look at the numbers. The global automotive industry operates on a scale that is genuinely hard to fathom. We're talking an astounding $2.2 trillion in revenue, employing over 8.3 million people worldwide. That is massive.
Now here's the crazy part. Balancing this massive, global scale with microscopic precision is exactly what makes building a car a true engineering marvel. It's kind of like building millions of highly complex puzzles where every single piece must fit together flawlessly every single time. And that is exactly what's happening on the modern assembly line.
Okay, so let's walk chronologically through the 4 fundamental steps every major automaker follows: stamping the skeleton, welding the body, the paint shop, and finally, final assembly.
Just look at the sheer complexity of this roadmap. Thousands upon thousands of components, stuff like electronics, plastics, and glass, all flowing in from a vast global network of suppliers. In fact, component manufacturers actually contribute more than 75% of a vehicle's total value before final assembly even begins. Crazy, right?
Step 1. Designing and prototyping.
Long before a single bolt is turned, the whole process kicks off in the digital realm, with engineers using advanced CAD software. But eventually, those digital blueprints have to be carefully translated into physical prototypes. Why? Well, because digital simulations simply can't account for every unpredictable variable out there in the real world. So it's only when the physical prototype passes grueling, real-world tests for aerodynamics and safety that the actual manufacturing gets the green light.
Step 2. Stamping the skeleton.
This happens in the press shop. Giant rolls of raw sheet metal are uncoiled, washed, and transformed into the car's structural skeleton. Powerful mechanical presses use custom dies to cut and stamp the metal into major exterior panels. And guys, the force required to do this is mind-blowing. These presses slam down with the equivalent weight of several adult elephants, just to shape those 40 to 50 major panels like the doors, the hood, the roof, with absolute zero room for error.
Step 3. Body in white and welding.
This phase is where the vehicle finally takes shape, and it introduces a universal industry term you'll hear engineers throw around all the time. So, what exactly is a body in white? Well, a body in white, or BIW, is simply the empty skeletal frame of the car before any paint or trim is added to it. This raw metal shell provides the absolutely critical structural integrity that dictates the car's crash safety, as well as its torsional rigidity. And torsional rigidity is exactly what dictates how smoothly your car handles a tight corner without flexing. To put that shell together, an average car requires over 2,200 precise resistance spot welds. And a major challenge here? Preventing something called molten weld splash. If that happens, it can completely ruin the structural integrity and create absolute nightmare defects for the paint job later on.
Which brings us to step 4, the paint shop.
Now, the raw, rigidly welded metal shell moves into a highly controlled, dust-free environment to get its protective skin. And painting isn't just some quick spray job. Notice the cathodic E-coating step right in the middle there? That step actually uses electrical currents to magnetically bind anti-corrosion protection directly into the very pores of the metal. After that, sealants, base coats, and clear coats are applied to make sure that finish is incredibly durable against the elements.
Step 5. Final assembly and the marriage.
This is the brightest, most labor-intensive phase where that empty shell is finally filled with all its functional parts. We get to see this beautiful symbiosis on the factory floor. Robots handle the heavy, repetitive lifting, like mounting those bulky tires, while humans provide the complex reasoning needed for delicate interior tasks. And increasingly, the factory floor operates almost like a giant brain. It uses a literal brain-thinking neurons pattern where smart sensors and AI vision systems act as the nervous system, instantly transmitting data to guide the robots. It allows them to adapt to different car models completely on the fly. It is amazing to watch.
Just look at the sheer volume of soft trims, wiring, and hard materials that must be meticulously installed into the cabin. From the headliner all the way down to the carpets, every single piece must be fitted perfectly. And remember, this is all happening while the car is continuously moving down a conveyor belt.
Installing the dashboard, or the cockpit, is incredibly complex. But notice how 3D robotic vision systems actually capture the exact geometry of the car to automatically install massive modules, like the entire cockpit, with total, absolute precision. It literally prevents errors before they even happen.
All of this builds to the most anticipated climax on the line, what they call the marriage. This is the highly choreographed moment where the fully assembled drivetrain and chassis are finally bolted to the body. As one Porsche production master beautifully put it, this is kind of like the creation. It's the moment life is truly breathed into the machine.
Step 6. Quality checks and delivery.
Following the marriage, the car looks complete, but before it can ever be sent to a dealership, it has to survive one final, rigorous gauntlet. Intelligent systems automatically fill all the necessary fluids. Lasers and cameras check that panel gaps and reattached doors meet incredible tolerances of under 0.3 millimeters. That is the exact precision that ensures your doors close with that satisfying thud and keeps all that annoying highway wind noise out of the cabin. Finally, the vehicle undergoes end-of-line dyno and track testing to ensure every single thing operates flawlessly.
The automotive assembly line is an absolute triumph of modern engineering. But the thing is, it's constantly evolving. As the industry implements deeper AI to monitor every microscopic assembly detail, and as we shift entirely from gas engines to heavy electric battery packs, we really have to ask, how will this century-old manufacturing process transform next? I really hope this explainer has given you a newfound appreciation for the incredible journey your car took before it ever hit the road.